Good morning, afternoon, evening, wherever you happen to be watching this class. This is the Chapter 3 review, and I am so glad that you tuned in for it, because it is an optional lecture. But that doesn't mean tune out real quick. This is stuff you need to know going into Chapter 3 that you already should know, but we're going to review it because it's things that people typically forget or maybe never even really learned in high school, or the last math class they were in. So we're going to give you a quick refresher on some points here that you're going to need going into Chapter 3. Hopefully it is just that. It's a refresher. You know it. You're all ready to go. If not, some stuff you want to brush up on. Now, the first thing we're going to look at are some properties of exponents. We have the property where a to the m times a to the m is the same thing as a to the m plus n. Okay. Essentially what that means is if I get, say, x to the 5th times x squared, no, that's not x to the 10th. It's x to the 5 plus 2, which is x to the 7th. Okay? Same thing here. A to the m over a to the n is the same thing as a to the m minus n. So when you're dividing, you're really subtracting exponents here. So if you get something like x to the 6th over x to the 4th, you can rewrite that as x to the 6 minus 4 and simplify that to say something like x squared. Okay? All right. Now, we need to look at negative and zero exponents, or zero and negative exponent. Little refresher here, anything raised to the 0 is 1. So if I ask you what 12 to the 0 is, you're going to tell me, Mr. Shipes, that is 1. A to the negative 1 can be written as 1 over a. So that negative exponent, if you want to get rid of it, you can just bring it down. Here as well, if it's not just a 1, if it has an actual exponent to it, so a to the negative n, I want to rewrite that with a positive exponent, I can just bring it down. So if I give you something like x to the negative 5, I say rewrite it without any negative exponents, just rewrite it as 1 over x to the 5th. Okay. This also works as well if you have x to the, say, negative 3 on the bottom, and I want to get rid of that negative, I can just bring that x up to the top. And that's going to be the same thing as x to the 3rd. Okay. Alright, so that kind of follows with 4 as well. So if you have a over b and both are raised to the negative n, if you want to get rid of that negative, you can just swap them and it gets rid of the negative. So that's all we did there. Rational exponents. If a is a real number, variable, or an algebraic expression, and n is a positive integer, where n is greater than or equal to 2, then a to the 1 over n is the same thing as the nth root of a, provided that the nth root of a exists. Okay, essentially what that means is if I ask you, what's 4 to the 1/2? You can rewrite that as simply the square root of 4, which is just 2, right? So it can work both ways. You can start here, go here. You can start here, go here. Solve it out, no problem. If a is a real number and m and n are integers containing no common factor, with n greater than or equal to 2, and then a to the m over n is equal to the nth root of a to the m, or the nth root of a raised to the m, provided that the nth root of a exists. So if I give you something like x to the 5 over 2, oof, written some rough 2's in my time, but that one ranks. Alright, you can rewrite that as the square root of x to the 5th, or you could rewrite that as the square root of x all to the 5th. No problem there. Now, there are some special binomial products that you should already know of as well, covered in Math 104. It is x plus a times x minus a equals x squared minus a squared. That's the difference of two squares. You've got x plus a squared equals x squared plus 2ax plus a squared. That's your perfect square trinomial. And you've got x minus a all squared is x squared minus 2ax plus a squared. That's also a perfect square trinomial. Now, of course, if you happen to ever forget these, you can just full it out. You can do that x plus a times x plus a, x and x, x and a and x, a and a, and you can full it out and you will get the answer. No problem there. Same thing for number 3. Factoring. You should know how to factor in already. You really should. But I'm going to hit you with a little review real quick. Now, there's several ways you can do this. You can identify, say for instance, that a is set up really similar to that difference of two squares. You got something squared minus something squared. Okay, you can do that if you want to. I use the X method a lot of the times. So the X method is something we'll go over. If you were to do the difference of squares here, what you would see is that, hey, square root of 9 is 3, the square root of x squared is x, and the square root of 25 is 5. So what we get is something that looks like this. You get 3x times 3x is 9x squared, 3x times 5, and negative 5 times 3x cancel out. Negative 5 and 5 is negative 25. Now, X method. I'll show it with you with part B. Part B. The way the X method works is you're going to do AC up top and you're going to do B down here in the bottom of the X. And then whatever you get, you're going to put it over A here. Okay? So the way this works is the number out in front of your X squared is your A, the number in front of your X is your B, and your constant is your C. Alright? So when I lay this out as an X method, I'm going to do 4 times 9, which is 36. And then I'm going to do negative 12 right here. You do need to keep the signs on these. Now, you can go ahead and put this over A here. A is a 4. But the number that needs to go on top of this fraction is a number that multiplies the 36 and adds to negative 12. So I need a number that multiplies the 36 and adds to negative 12. Well, let's see. 6 and 6 is 36, and 6 plus 6 is 12. So if I use negative 6 and negative 6, that multiplies the positive 36 and adds to negative 12. I'm good to go. Now what we're going to want to do is we're going to want to reduce these fractions as far as we can. I'm going to reduce this to negative 3 over 2, and this to negative 3 over 2. And the way this helps us is we take the bottom number here, and that's the number that goes in front of our x. 2x, and this number is our constant, minus 3. Now we'll go to this one, and in our second parentheses we've got a 2x, and our constant is minus 3. So this factored is 2x minus 3 times 2x minus 3, which you could also write as 2x minus 3 squared if you'd like. That's the X method. Alright, so now let's look at C. C is 3x squared minus 14x minus 24. Let's work the X method on this one. So AC is going to go up top. That's going to be 3 times negative 24. And B is going to go on the bottom. That's negative 14. Now, I'm going to write it a little bigger because I kind of crammed the space in there. Now, 3 times negative 24 is going to give us negative 72. Okay? Now, our A here is a 3, so I can go ahead and put it in the denominator right here. I'm going to erase this to give us some more space. And I need two factors of 72 that add to negative 14. Two factors of negative 72 that add to negative 14. So if I'm thinking about factors of 72, the ones that stand right out are 9 and 8. 9 and 8 are factors of 72, but they certainly don't add to 14 in any kind of manner. What's some other ones we might have? How about 4 and 18? 4 and 18 will work, especially if I make the 18 negative. Okay? So if I make the 18 negative, negative 18 and positive 4 is negative 14. Negative 18 times 4 is negative 72. Now all I have to do is reduce, if possible. Now I can definitely reduce this side. This side will reduce to, let's see, I can divide both by 3. That'll give me a 1 there. And negative 18 divided by 3 is negative 6. So the way that I'm going to set this one up is going to be 1x minus 6 times 3x plus 4. And now I have factored part C. If you want to, you don't even have to put the 1 in front of the x. It's imagined to be there. It's known to be there. And you can write it very simply as x minus 6 times 3x plus 4. There you go. Let's do D. Let me change the color so we don't get too mixed up here. I'm going to do the x from D over here. Let's see. So 6 times negative 1. That gives me a negative 6. Alright, and let's see, -1 is my b here. I need two things that multiply to -6 and add to -1. Two things that multiply to -6 and add to -1. How about -3 and 2? That works. That'll reduce to 1/3 here, and that'll reduce to -1/2 here. So that I get 2x minus 1 times 3x plus 1. Now this is the point where I say, if you have another method of factoring that works for you, you do not have to learn and do the x method. By all means, if you know a good way of factoring that gets you to the answer, use it. I'm just showing you the x method because that's how I teach it. You do not have to know the x method. If you don't do the x method on your work, that's fine. As long as you can get to your answer, I'm happy with whatever way you can work it out yourself. Alright, let's choose another color and we will do E. So let's do a nice X for E. We've got a 10 here and a -5. That's going to give us -50. We've got a 23 here. Oof. So I need two numbers that multiply to -50 and add to 23. I'm going to put both of them over 10. Factors of 50. How about 2 and 25? If I make the 25 positive, 25 minus 2 gives us 23. 25 times -2 gives us -50. We're good to go. Let's reduce. So this will give us -1/5. We'll reduce this one. 5 will go into both of these. 5 goes into 25 5 times. 5 goes into 10 2 times. So now I can just write it as 2x plus 5 times 5x minus 1. And I've factored E. Simple as can be. Now the only thing about the x method that I'll also throw out, it needs to be as reduced as possible before we do the x method. And what I mean by that is if you can pull out any constants, you need to do that before you do the x method. So if this would have been a 25 instead of a 23, I would have needed to have pulled a 5 out of this and simplified it as far as possible before I could do the x method. Otherwise the x method won't quite level out the way you need it to, because it'll factor out that constant and you'll forget to write it. Now, complex numbers. You do need to know a bit about complex numbers. We're going to get into them, especially when we do the quadratic method later on this chapter. Now, the number ax plus bi, in which a and b are real numbers, is said to be a complex number in standard form. The a is the real part of the number, and bi is the imaginary part. If b is equal to 0, the number a plus bi equals a. Obviously, because 0 times I, anything times 0 is 0, so that just leaves you with the a. Is a real number, and if b is not equal to 0, the number a plus bi is an imaginary number. Okay? If a equals 0 and you're just left with bi is a pure imaginary number. A little refresher here as well, since we're on it. I is the square root of -1. So I squared is just -1. There you go. Good bit of information to know as well. We have finished the review. Now you can log into the Blackboard and pull up chapter 3.1 and get started with the bulk of the material for chapter 3. If you have any questions with the review, feel free to reach out to me and let me know. This is stuff you should already know, so you might have to do a little personal research on YouTube or any other math resource that you're comfortable or familiar with to help brush up on some of these facts, because this is something that you should have known as a prerequisite coming into this course, but I did want to do you a little bit of a favor, kind of brush up, help you review some of them. See you at chapter 3.1.